Today I'll be talking to you about how to leverage unikernels to make better deployments. But first, a little bit about me. I'm from Argentina, which is the land of Messi, and even if you hate soccer or football, you probably heard the name 1,000 times. We also have tango, but we don't dance it very much. We have lots of cows that we really like a lot. And then we have a lot of financial crisis and hyperinflation. Just a quick question, who knows, who can guess what this picture is? A drug deal, probably. It's actually an Argentinian's wallet, right? And if you actually go as a tourist and you bring your dollars or your euros in and you go exchange pesos, this is probably what your wallet's going to look like. Okay, so that's enough about me. So let's get started. First, a bit of a quiz. What's the fastest a VM can cold boot? Any guesses? Any order of magnitude guesses? 10 seconds, okay. Yeah, something else? How much? 2 seconds, okay. So I actually did a multiple choice and I cheated because I didn't give you the choices. So A, I have time for lunch. B, I have time for just a coffee, a few seconds, or a few milliseconds. And basically, I'll show you that you can actually do it in a few milliseconds in a fully hardware isolated virtual machine. Okay, second question. How many virtual machines do you think I can stuff into a 64-core server? 64, fair enough, yeah? 100, okay. 256, okay. All right, so again, I had one Ubuntu-based one, tens of them, hundreds if I'm feeling adventurous, and 90,000 before my system begs for mercy, so I'll show you a little bit about that. Okay, so, and the final one, I promise no more questions. Who knows what a unikernel is? One hand over there. Okay, so a specialized VM, right? Option one, a corn cob with a single kernel. A uni what, right? Fair answer. And tech I heard of in the past that I feel the Argentinian guy in the front is going to try to pedal to me today, right? And so, yeah, it's A and D, but also C is a valid answer if you don't know what it is. And hopefully by the end of the presentation, you will know what it is. So a little bit of a story. Imagine I want to deploy an application. Let's take Nginx on the cloud. There's 100 ways to do it. One way is to go to the AWS marketplace and maybe pick up this Ubuntu image. And you put those two together, and you end up with a fairly sizable image of a couple of gigs, right? Nginx itself is relatively small, and what we'd really like is be able to build an operating system and distribution that can run just Nginx and nothing more. And that's what Unikraft is trying to do. And if you put those two together, you can run Nginx in a 2 meg image. So just a few more stats. This is kind of comparing Linux on the left-hand side with Unikraft, both running Nginx, both running on EC2 instances. And if you measure things like boot time, you can imagine seconds for the Linux VM. In Unikraft, it's milliseconds. Memory consumption severely goes down. And then at the bottom, I already mentioned the image size, right? So how does this work? Well, basically specialization, right? So if you have the application, in this case Nginx, you have components for it, and underneath you have system libraries. You have the kernel with its components, but pretty much the application probably needs the highlighted bits to run and nothing else, but everything comes with it. So what we like to do is take some sort of magic wand and grab only on those components and build a specialized VM. And that specialized VM is called a unikernel. And what Unikraft is, other than an open source Linux Foundation project, is a unikernel SDK that lets you build these unikernels relatively easily. And you can go check that out at unikraft.org. Okay, so Unikraft has 3 basic principles. The first one is that it's fully modular, and this allows for specialization. Everything in Unikraft is a library, so memory allocators, whatever it may be, you can sort of plug and play them based on what the application actually needs. And this is what allows us to get these really nice stats that I've been talking about. The second part is that we keep Linux API compatibility. So if it runs on Linux, we should be able to run it. And so you can keep running unmodified apps and languages. And the third part is tooling integration. We do a lot of work to make sure that you can kind of run things with Kubernetes, Docker, and then Terraform. Okay, so that's Unikraft, and what we did is we started putting together a platform called Kraft Cloud based on that technology. This is a very simplified diagram of one of our Metro platforms. We run bare metal servers with KVM, and then on top of that, we run Firecracker with some modifications, and we have a control plane agent that we wrote from scratch, which exposes a REST API. We have a registry that we have stock images, and users can also push images to, and then obviously the platform pulls from these registries to run things. And then on top of that, you have the actual instances. Could be Nginx, could be SQLite, could be any number of applications. Okay, so with this in place, we did a number of performance measurements. In this case, we're using a 24-core system with 64 gigs of memory, and for the host, we're using Debian. Okay, so this very first one, this is called boot times when running Nginx. So on the x-axis, you can see the number of instances we're actually booting. So these are actual VMs, hardware-isolated VMs. And on the y-axis, you can see boot times in milliseconds. And so what I'm doing here is I'm booting one VM, I'm measuring its boot time, I leave it running, I take the second one, do the same thing, leave it running all the way up to 5,000. You can see that you can get boot times of about 7 milliseconds, 6 milliseconds, all the way up to 14. It can vary a little bit depending on CPU frequency and other factors, but the order of magnitude, it's about this. This is a table that shows some other applications, not just Nginx. So you have Redis, SQLite, Node. And here we're comparing Unikraft in the middle column to Linux. I'm not going to read the numbers, but you can see there's at least an order of magnitude difference. Another nice feature that comes out of eliminating a lot of code at build time before you deploy is you get a lot of reduction in TCP. So I mentioned the image sizes that can go Linux, this is Nginx by the way, from 30 megs. This is when we build a purpose-built minimalistic distro for just Nginx on Linux, to be fair. It's 30 megs, and Unikraft is 1.9, as I mentioned before. Or if you enable dead code elimination, it's 1.2 megabytes. What really gets reduced also is the lines of code, because the Linux kernel has millions of lines of code, and with Unikraft you can run the same application unmodified with hundreds of thousands of lines of code only. Okay, so we did some throughput measurements here. We're using WRK and Nginx for different request sizes on the x-axis. And Linux is the bottom line, the red one, Unikraft is on top. And for most packet sizes, except the larger ones where things kind of merge, you can see Unikraft outperforms Linux. Okay, what we did here is we wanted to find out, I kind of alluded this in one of the quiz questions, how many VMs can I actually stuff in a server? For this server, we used something a little bit bigger, 64 cores, and 1 terabyte of memory. Just like before, we start one VM, measure boot time, and then we go all the way as far as we can. And in this case, we got very close to about 100,000 before the server kind of ran out of memory. Of course, we're never going to run these numbers in production, but it kind of shows a little showcase of what the technology can actually do, right? This is an equivalent memory consumption graph, up to 5,000 VMs. I'm not really going to go into the details of it, but you can see it scales linearly. And even when you're running 5,000 VMs, in this case, the server, we're using about 40-some gigs of memory, which is certainly feasible. And then final comparison of image sizes, in this case against Docker, and you can see also there's an order of magnitude reduction. Okay, so a little demo. So of course, you're never supposed to do a demo because you're going to anger the demo gods. If you're going to do one, don't do it live because that's pretty bad. And if you're going to do a live one, don't do it remote. And if you're going to do a remote live demo, don't do it over Wi-Fi, right? So I don't know. Let's see what happens. Okay. So what I'm going to do here is I have some scripts that are going to talk to the REST API. We have a Metro in London. So I can just show you what they look like. They're pretty simple, right? They're just wrappers around curls. So first, I'm just going to list. It says there's nothing there. And then I have a script that is going to create 500 Nginx unikernels, so fully isolated VMs in one go. So you can say we're basically saying Nginx. Sorry. Did it go away? Okay. Aha. Now you can believe me, right? Thank you. Probably better now, right? Okay. What's tricky is now I only see it there. So anyways, let's see. Okay, so basically I have a script. Let me just cut it up here. Yeah. That is basically going to create 500 Nginx instances. You can see the number 500 here. Let's go ahead and run it. Right. There it is. So it's done. It took about a second to create all 500 instances. You can sort of see it's reporting. Yeah, there we go. So 6,000, that's in microseconds. So that's 6 milliseconds for that last instance. It's reporting a DNS name. So let me see if I can actually grab that out. It's funny that the monitor is so far away. Okay, let's see. Okay. Right. So what's worse than typing backwards, right? Okay. Okay. Oops. Yeah, I can't quite see what I'm doing. So anyways, what that's going to pop up, let's see, what did I copy? One more time, and if it doesn't work out, I'll move on. Right. Okay, so all of these instances are completely separate. They all have their own UUIDs. They all report their own individual stats. Okay, and if I then go back to this, I can delete them all. Okay, and they're all gone, so I can, if I list it, you can see there's nothing left. And I can also create, I have a node one, and there it is, it created it. It took about 20 milliseconds, and then same thing. Okay. Okay, there's no JS. Okay, I think that's as much risk as I want to take with a demo while typing backwards. So I'll move on. Okay, so yeah, apparently I was saying there's maybe less than a 1% chance of success. I'm happy enough. Let's move along. So tooling, as you saw, I was using REST API with curl commands. That's the rawest access to the platform. We also have a tool called Kraft, which is part of the open source project. This is the native tool of Unikraft. And we are releasing Docker file support, so you'll be able to say Kraft Cloud deploy and then Docker file, and then Kraft Cloud commands will wrap around all of the REST API stuff that I was showing. Another thing that we're working on this month is Terraform support, so you can write your HCL file and do deployments via Terraform apply. And then finally, what about Kubernetes? We're doing this also this month. We're doing it via Crossbrain provider, where essentially you'll be able to take a standard Nginx YAML file and then state that you want to deploy. In this case, it's saying Frankfurt, and then you can just do standard kubectl apply. All of this is coming this month. Okay, so that's basically it from me. I hope you enjoyed the talk and some of this sounded kind of interesting. If it did sound interesting, you can go to craft.cloud and sign up. This stuff is in closed beta, so you can just go ahead and sign up, or you can tackle me as I walk down the podium. Probably that's a more efficient way to get access. Other than that, I'm always looking for feedback, so there's my email address, and thanks for listening, and I'll take any questions you may have.